Have you ever wondered how data formats can impact the speed of your deep learning models? If you're working with TensorFlow and cuDNN, you're in the right place. Today, we're diving into the performance differences between NCHW and NHWC formats. I totally get it. The choice between NCHW and NHWC can feel overwhelming, especially when you're trying to optimize your model's performance. You're not alone in this confusion. Many developers face the same dilemma. Here's the specific question we're addressing today. One user asked, how much faster is NCHW compared to NHWC in TensorFlow and cuDNN for convolution? They also want to know why NCHW is faster and if there are any benchmarks to back this up. Sound familiar? Let's explore this together. So what makes NCHW faster on GPUs? The TensorFlow Performance Guide mentions that while both formats are supported, NCHW tends to perform better on GPU due to how memory is accessed and processed. Let's break this down further. And stick around. At the end of this video, I'll share some valuable resources and benchmarks that can help you make the best choice for your projects. To understand the performance difference between NCHW and NHWC formats in TensorFlow, the user should first look at the nature of convolution operations. NCHW format is generally faster on GPUs because it optimizes memory access patterns. Next, the user should consider the benchmarks available for these formats. Various studies and benchmarks indicate that NCHW can be significantly faster, often showing improvements of up to 30% or more in certain scenarios. Now let's discuss why TensorFlow transposes NHWC to NC internally. This is primarily because the cuDNN convolution kernels are optimized for NCHW, leading to better performance compared to NHWC. Finally, the user should be aware that while NHWC is supported, it may not be as optimized as NCHW. The performance gap can be attributed to how memory is accessed and processed in these formats. Fun fact, the choice of data format can be as crucial as the choice of model architecture in deep learning. It's like choosing the right tool for the job. Sometimes the smallest details make the biggest difference. Now, let's look at the answers provided by other users. According to a user, as of TensorFlow version 1.1, you cannot directly use the NHWC format. TensorFlow automatically converts data to and from NCHW. This means that, from a user's perspective, NCHW is generally faster. The performance difference can vary depending on the specific problem, but it's suggested that using NHWC on GPU should be avoided, as it may waste memory and lead to slower performance. That's it for that response. Let's explore another one. This user suggests that manually optimizing the data layout may not be necessary. They believe that the performance difference between NCHW and NHWC is minimal, estimating at most a couple of % faster training times with NCHW. They also mention that as XLA-JIT compilation improves, this difference may diminish over time. They recommend experimenting with both formats using Keras by setting the image data format with the command cat set image data format. Additionally, they provide a link to a small benchmark comparing performance with a VGG model. Now, let's dive into a different answer from another user. This user explains that on the CPU side, the performance difference between NCHW and NHWC formats mainly arises from how data is accessed during the IM2 call operation. For NCHW, the data access pattern requires jumping between rows and channels, which can slow things down. In contrast, NHWC allows for more efficient memory copying as it processes data in a more contiguous manner. They note that while GEM operations are highly optimized, the IM to call step is where NCHW faces its biggest penalty. On the GPU side, the user admits they don't have much information yet. However, they highlight that the differences in performance may also depend on how well the cuDNN kernels are optimized for each format. Here's a pro tip. Always benchmark your models with both formats on your specific hardware. This can save you time and help you choose the best option for your needs. And there you have it. Understanding the differences between NCHW and NHWC can greatly enhance your model's performance. If you found this video helpful, please subscribe for more insights, and don't forget to check out the resources linked below.